Welcome to another deep dive. And today we're getting into some really cool stuff. Specifically, we're talking about machining hard materials and a company called ISCAR and their new line of end build.
I've heard about these.
These are the ECA2s.
Okay, yeah.
And they're exciting. They're specifically designed for these super tough materials. So think like the hardened steel you'd find in like dies and molds for, making car parts or electronics.
Right.
And what's crazy is we're not just talking about like incremental improvements here. These tools are bringing some pretty wild tech to the table. Like we're talking micro level precision coatings that sound like something out of a sci-fi movie.
Really?
And the performance is supposed to be like a total game changer for manufacturers.
So before we get too deep into the ECA2s themselves, can you just give us a quick rundown of why working with these hard materials is even a challenge in the first place?
Yeah, so basically it all comes down to the materials themselves. Hardened steel, by its very nature, is designed to resist wear and tear.
Right. Which is great for the final product, but it makes it an absolute pain to work with. Traditional cutting tools wear down incredibly quickly.
Oh, yeah.
Which means you're constantly having to replace them. Production slows down. And of course, your costs go up.
So that's where these ECA2s come in.
Exactly.
How are they tackling these challenges?
Well, ISCAR has really gone all out with this new generation. They've actually replaced their previous ECA2 line, specifically the ones in the smaller diameters, so 0.3 to 4 millimeters.
Okay.
And they've focused on three key areas: material, geometry, and precision.
Let's unpack that, starting with the material.
Okay.
The specs mention this, IC602, and aluminum titanium silicon nitride PVD coating. I mean, what is going on there?
All right, well, IC602, that refers to an ultra-fine carbide substrate. Think of it as the foundation of the tool. And this specific carbide is known for being extremely hard and durable, which are both essential when you're dealing with the stresses of cutting hard materials.
And then you've got that coating.
Ah, yes, that's where the real magic happens. So that's a multi-layered coating applied using a process called physical vapor deposition.
Okay.
It's actually pretty wild. They basically bombard the tool with ions of aluminum, titanium, silicon nitride.
Right.
And that creates this super thin, incredibly hard surface layer.
You're not just talking about toughness, you're also reducing friction, right?
Exactly. That coating acts like a shield. It reduces friction. It reduces heat buildup during the machining. And that not only extends the life of the tool, but it also means you get a better quality cut.
You're able to run it longer at higher speeds.
Exactly.
Less wear and tear. Huge win for manufacturers.
Absolutely, in terms of both productivity and cost savings.
Okay, so let's move on to the geometry of the ECA2.
Right.
What's going on there?
Another area where ISCAR has made some really smart moves. So they've optimized the shape of the cutting edges. Specifically, they've gone with a small land and a large radius.
What does that mean in practice?
Think of it like this. A sharper knife cuts through material more easily, right?
Right.
Same idea here. That small land helps concentrate the cutting force, so it can really penetrate that hardened steel. And then that larger radius, that helps to distribute the stress and prevent chipping, which is obviously crucial for the tool to last a long time.
So it's strength and smart design together.
It all comes together.
And then you mentioned precision.
Right.
What's special about the precision of the ECA2?
So the ECA2 has incredibly tight tolerances, both in terms of diameter and corner radius. We're talking micrometers here.
That's tiny.
Oh, yeah, super tiny. But in the world of die and mold manufacturing, that level of accuracy is absolutely essential.
Okay, so we've covered the why. We've covered the how. Let's talk about where these tools are actually being used.
Right.
What industries are benefiting the most?
Well, the die and mold industry is a perfect example. Think about it. All those products that rely on super precisely shaped molds, automotive parts, electronics, even those fancy chocolate molds we were talking about earlier. The ECA2 allows manufacturers to create those intricate and precise molds, which leads to higher quality products.
What about the actual machining processes?
So these tools are great for both roughing and finishing applications.
Okay, so remind me, what's the difference?
Sure, so roughing, that's the initial stage, where you're taking off large amounts of material just to get the basic shape.
Right.
And the ECA2, with its strength and durability, can handle that heavy lifting really efficiently. And then you've got finishing, where you're refining the details, getting that perfect surface finish. And that's where the precision of the ECA2 really shines.
I imagine this level of performance has got to have a ripple effect throughout the whole manufacturing process.
It's not just about machining faster. It's about machining better. Less tool wear means less downtime, less time spent changing tools. Production speed goes up. Costs go down. It allows manufacturers to be more competitive and really push the boundaries of design and innovation.
I mean, it's amazing to think that these tiny little tools can have such a huge impact.
It really is.
On entire industries.
It's a testament to how all these different fields, material, science, design, engineering, can come together to solve these really complex challenges and drive innovation.
So to wrap things up, it sounds like these ECA2 end mills, they're pretty much revolutionizing the way we work with these hard materials.
Absolutely. They're really pushing the boundaries of what's possible.
And with technology moving as fast as it is, who knows what's next for machining and manufacturing?
Possibilities are endless.
Well, this has been a fascinating deep dive. Really appreciate you walking us through all this.
Anytime.
And for everyone listening, thanks for joining us. Until next time.